All right, so this has been a really long lesson so far, but y'all just stick with me. We got four proofs left. Four proofs left. Okay, so we're on page 11. Now up here it says CPCTC proof number one. Now we've already talked about our five congruency tests. We've already done two proofs for each one of those. So now this CPCTC thing pops up. So recall from 5.2 when we talked about corresponding parts. Well, that's all this is right here. Is this is saying the corresponding parts of congruent triangles are congruent. That's what CPCTC stood for. Okay, so these proofs, they look very similar. In fact, we're using some of the same figures, but they're asking us to prove different things. They're not asking us to prove necessarily that two triangles are congruent. That's kind of implied in the actual thing they're asking us. So let's look at this one, page 11. We're given that x is the midpoint of segment VZ and x is the midpoint of WY. And then using those two pieces of information and these pictures, we're asked to prove that angle XVW is congruent to angle XZY. So this is different from the other proofs we've done so far. They're not asking us to prove two triangles are congruent. Instead, they're asking us to prove that two angles are congruent. So that's where the corresponding parts are going to come in. So let's just go through. Let's first determine that these two triangles are congruent. Then we can get into the actual stuff we need to prove. So x is the midpoint of VZ. We already kind of went through this one, so I'll kind of speed through it. X cuts VZ in half, and it creates two new segments, VX, and this should be ZX. So my first two segments, x is the midpoint of VZ, that's given. And then after that, Vx is congruent to Zx by definition of the midpoint. Next given statement, x is the midpoint of Wy. So x also cuts Wy in half. So here we are. That'll be our third statement. Our fourth statement will be these two half segments are congruent. So Wx will be congruent to Yx by the definition of a midpoint. Okay, next up we need to determine that these two triangles are congruent. We have two congruent sides at the moment, so our only options are side, 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 and side angle side. So we need to look for a reflexive side or a pair of vertical angles. We have a pair of vertical angles here. These angles are angles VXW or WXV and YXZ. So these two angles will be congruent because they're vertical angles. So now to make sure that we have proven these two triangles congruent, we're going to cover up one. We've labeled in the order side, angle, side. If we're just going around our triangle, side, angle, side, either way we go. So these two triangles, triangles XVW and triangles XZY, they're congruent by side, angle, side. Now, keep in mind that's the way I needed to word it. XVW and XZY. If we look, XV right here, XV has one tick mark. So if I'm naming my first segment to be the one tick mark side, when I'm naming my other one, it needs to be the one tick mark side. That's why I said angle XVW and angle XZY instead of saying triangle XVW instead of triangle XYZ, because that would be corresponding parts. So my sixth statement is that triangle XVW is congruent to triangle XZY by side angle side congruency. So now the thing that I set out to prove originally, angle XVW is congruent to angle XZY. Okay, so the two angles that they wanted me to prove congruent, and I'll do it in different colors just so we have it marked very clearly. So angle XVW is up here, and angle XZY is down here. Well, since we have already proven these two triangles to be congruent, so I prove these triangles to be congruent by these two sides and these angles. So as long as I've already proven them to be congruent, then that means that the other corresponding parts will be congruent as well. So these two angles that we were looking for, they are congruent. These other side lengths must be congruent, so VW and ZY. And then this last set of angles right here, which I'll mark with 3 lines, would also be congruent. But ultimately, the one that I was setting out to prove was angles XVW and angle XZY, and they are congruent because of CPCTC. The corresponding parts of congruent triangles are congruent. So with these, like I said, they're a little bit different because these were our end goal. Our end goal is not to prove these two triangles to be congruent, but instead to prove that their corresponding parts are congruent. So let's look at another one. Okay, this is page 12, CPCTC proof number 2. We're told from the get-go, QS is congruent to TS, R is the midpoint of segment QT, and we're asked to prove that angle RQS is congruent to angle RTS. So, go through step by step. First statement, QS is congruent to TS. That'll go down here in our first statement. First reason is given. Mark it on our picture. Next up, R is the midpoint of QT. Write that as our second statement. Write given as our second reason, and we'll go through and mark it. So if R is the midpoint of QT, that means that that midpoint bisects this segment, meaning it cuts it in half. So when we do that, we've got two new segments that pop up that are congruent to each other. And these two segments are segments QR and segments TR. And these two, let me put two tick marks because we don't necessarily know if these two are the same. So we know QR and TR are congruent by the definition of a midpoint. We don't have any more given statements, so when you look for either a reflexive side or a pair of vertical angles, we do have a reflexive side right here. So the SR of the left triangle is congruent to the SR of the right triangle. So that's my fourth statement, and this is by the reflexive property. So now at this point, I wanted to figure out if these two triangles are congruent. I'll cover one up. Going around the triangle, I've got side, 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 side. Doesn't matter which order I start in, where I start, I've still got side, side, side in that order. So I can say these two triangles, triangles QRS and triangles TRS, are congruent by side, side, side triangle congruency. And again, when you do name these two triangles, when you do make this statement right here, which is your congruency statement, make sure you put it in the right order. So QRS is congruent to TRS by side, side, side congruency. So if we do know that these two triangles are congruent by all their side lengths, that means their corresponding angles must also be congruent. So we set out to prove that angle RQS and angle RTS are congruent, and that is exactly what we have done. So my last statement, angle RQS is congruent to angle RTS because of CPCTC. Corresponding parts of congruent triangles are congruent. All right, page 13, CPCTC proof number 3. Given AC bisects angle BCD and angle ABC is congruent to angle ADC. So having those two bits of information and this picture, we need to prove that segment AB is congruent to segment AD. So first up, AC bisects angle BCD. That'll be our first statement. We'll write it here. Our first reason will be given, and then we'll mark it on our picture. So AC bisects BCD. Now, when we bisect something, we cut it in half. So that means we have two new angles that are both half of the original angle. So angle BCA is congruent to angle DCA. That'll be our second statement. They're congruent by the definition of an angle bisector. Now, next up, my second given statement is that angle ABC is congruent to angle ADC. So I'll mark that. ABC and ADC. These two angles are congruent. That is given to us. So I'm out of given statements. I need to look for either a reflexive side or a pair of vertical angles. So I have this reflexive side here, side AC. So if I was to pull these two triangles apart, then that means that the AC of the top triangle would be congruent to the AC of the bottom triangle, and this would be by the reflexive property. So now, if I was to cover up one triangle and then list the parts that I have labeled in order, I would have angle, angle, side, or even if I went reverse order, side, angle, angle, which when you reverse is still angle, angle, side. So I can say that triangle ABC is congruent to triangle ADC by angle side, triangle congruency. So now we refer back to our proof statement, which was that segment AB must be congruent to segment AD. Well, if we look at our congruency statement down here, that seems to make sense. AB being the first two letters here, AD being the first two letters here. So that means that these two segments up here must be congruent by CPCTC. All right, so last one, page 14, CPCTC proof number 4. So we are given that segment WV is parallel to segment YZ. We haven't seen that symbol so far today, but that just means parallel. And X is the midpoint of segment WY. Using those two bits of information and this picture, we need to prove that angle WVX is congruent to angle YZX. So if we're told, first off, that our first given statement is WV is parallel to YZ, we'll write it here, write our reason it's given, and then we're going to label it. So keep in mind, we do label parallel sides with those little arrowheads. Two sides, whether it's in a diagram, in some kind of a figure, if two sides have got two little arrows on them, that just means they are parallel. They will never intersect. So this next one might be a little bit difficult to understand, but with parallel lines, then we kind of think back to Unit 4 when we talk about all the different angle relationships. Okay, and so one angle relationship that we could make, one observation that we could make, is that there probably are going to be some alternate interior angles that pop up here. Okay, because we've got two parallel lines here. Then inside the mix is the interior. You remember, anything between the parallels would have to be the interior. So I could make the statement that there could be some interior angles involved in this picture. Okay, so in this picture, I could say, maybe if I'm talking about angle VWX, well, VWX would be the same thing as ZYX, because if I was to just ignore some of the rest of the stuff that I've got going on in here, if I was just take out one of these lines right here, I would have inside the parallels, these are both on the opposite side of this segment, so they're on alternate sides. They're both in the interior, so these two are alternate interior angles, which would be congruent. So we can say angle VWX and angle ZYX. They are congruent because they're alternate interior angles. Okay, next given statement, X is the midpoint of segment WY. So midpoint bisects a segment. So we got this segment and this segment. So we would say that WX is congruent to YX, and this is by the definition of the midpoint. So we are out of given statements. We need to look for a reflexive side or a pair of vertical angles. We do have a pair of vertical angles. It's going to be right here. So in doing that, we can now cover up one of these triangles to see if one of our tests fits, and it does. We've got angle, side, angle, angle, side, angle. Even if we cover up this one and do the other one, angle, side, angle, angle, side, angle, in that order. So we can say that these two triangles are congruent by angle, side, angle. So we'd say triangle VXW and triangle ZXY. They're congruent by angle, side, angle. So if we've proven these two triangles to be congruent, then we've proven that all of their other corresponding parts to be congruent. And so one set of corresponding parts that we would have is my last set of angles. Angles WVX and angles YZX. Now, earlier in my proof when I was talking about the alternate interior angles, I could have also listed these two angles right here, angles WVX and angles YZX, and they both also would have classified as alternate interior angles. But since I was setting out to prove that these two angles were congruent, that's why I went with my other option. That's why I said that VWX was congruent to ZYX. Now, again, knowing that these two are parallel, these two blue angles were also alternate interiors, but just given the way that my proof was set up, that was the direction I decided to go.